Let's talk about batteries and capacitors, the difference and similarities between them. Well, they're both things that have to do with electricity. Yeah, they do, so I guess they got that in common. But they can look alike, but they're not necessarily, they're not necessarily, they're not the same thing. So here I have a capacitor, and here I have a battery. Yeah, this is a 6-volt, something called a lantern battery. This one's actually a dead battery. I used to be able to go, put my tongue on it and still get a shock out of it, a little tingle, but now it's dead. And still, but the battery wouldn't work, but I could still get a little bit of a tingle out of it. It's beyond tingle. This thing has been so dead for so long that it doesn't even tingle anymore. My point is, though, even with a dead battery, you can still have some voltage. This is a 6-volt battery. We could connect a voltmeter to it and potentially even get some voltage still left in it, but just not enough to do anything that we needed to do. The voltage has gone down too much. But you could have a dead battery, still have a voltage, like a 1.5 volt battery. Oh, here's one. Here's a 1.5 volt battery. All right, there we go. Oh, this got a little poopy stuff on it there. That's not good. This is probably a dead battery. It says good till 2025, but that stuff would tell me that it's leaking, and that ain't a good thing. But anyways, don't touch that stuff too. It'll acid reaction on your fingers. You'll melt and melt. So don't do that. But anyway, point is, this is the battery. It's 1.5 volts. Okay, 1.5 volt battery, D-cell battery, 1.5 volts. Of course, you know there are AAA batteries and AA batteries and C batteries, all these different size batteries. Of course, a lantern battery, really big. A 9-volt battery, yeah, that's a small one. That's 9 volts, but 9-volt battery. This is a 6-volt battery. But all those other batteries I just mentioned, the AA, AAA, the C, and the D batteries, those are all 1.5 volts. So really all 1.5? Yes. So even your AAA battery, that little one, little tiny cute little battery, is 1.5 volts, and opposed to the D-cell battery, 1.5 volts. Well, why is that? Because they're all standardized. Now, well, why do you have a large battery and a small battery? Well, it depends, you know what you need it for. You're going to need a AAA battery to put into your little clicker/remote. I say clicker. Okay, the wife says remote. So you say potato, I say potato, whatever, who are you? Are you a remote person or a clicker person? Clicker. So anyway, the clicker has 1.5 volt batteries in it, but they're, AAA, because the clicker is not very big. Try stuffing like a few of those in there and see how that works out for you, okay? Not going to work. So you have the size of the battery corresponding to the device that you're using it to. That's all, but they're all 1.5 volts. Back to this one. So you can still have a 1.5 volt battery, and it might register on a voltmeter as 1.3, but it doesn't work anymore. It's dead. Still can have voltage though. It's just that what happens is inside the battery, at the poop, I call it the poop just builds up and it doesn't allow flowage anymore. What are you talking about? Let me show you. So this is, dry cell battery. Oh, there are also dry cell batteries and wet cell batteries. A dry cell battery, if you were to open this up, cut that open. I've done that before. You cut it open and there's all this pasty stuff inside. And don't touch the pasty stuff and rub it in your eyes, okay? That would not be a good day for your eyes. But the pasty stuff, this is a dry cell battery because it's dry inside the battery. There are wet cell batteries. You know this. Well, you might not know that you know, but you do. What does that look like? Looks like my car battery. Exactly. In the car battery, you got a positive and negative terminal, just like on any battery. You have a positive and a negative terminal. On our D-cell Duracell here, we have a positive up here, and the negative's on the bottom. Positive at the bumpy is positive, and the negative is on the flat part. So a positive and negative terminal. This, of course, is a 12-volt battery. Did you know that? 12 volts in that car. Now, you can't just use one of these to start your car. Your car is your car. It's pretty big, so you get a little bit more voltage than 1.5. So 12 volts. This is called a wet cell battery because inside there's a solution of sulfuric acid, and that sulfuric acid has ions from the hydrogen from the acid and the sulfate ions. Two, because H2SO4, so we got 2 hydrogens for every deionization of the acid, and it breaks down to the sulfate. Chemistry, so much fun. Okay, it's one of the good sciences as well. Okay, physics, chemistry, all others, biology. I can't even reach far enough down for biology. Okay, that's where that one ranks. Yeah. So anyway, 2 hydrogens in a sulfate, called a wet cell battery. As long as we have some ions floating around. This is universal for floating. You do this anywhere in the world, they know that you mean floating, okay? Now, you do that in Germany. You mean floating, yeah. Yeah, exactly. So that's a wet cell battery. But we'll stick to dry cell batteries, or dry cell Our Duracell copper top battery, boop, 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 has the bumpy at the top, up here. That's the positive. Down here's the negative. Inside the battery, if you cut it open, you'll see this carbon rod in there. I'm just going to show you, what a battery is. It's not like you have to know the chemistry within the battery. That's electrochemistry, by the way. That's a section of chemistry. Kind of a little bit of physics there too. But we should know a couple basic things about a battery. Is that there's a chemical, in the pasty stuff, there's a chemical reaction that goes on in here. It's called a redox reaction. Redox, okay, you've heard of redox. I got a pair of those back home in my closet. I like to wear those on my feet sometimes, my redox. Reeboks, funny. So yeah, the redox is a reduction oxidation reaction. Again, I'm not gonna go into the chemistry behind it, but what we need to know is that when this happens, it releases electrons. It releases electrons. And it's those electrons that allow us to use the battery to do work. It's moving electrons that allow electricity. Electricity, electrons. Get it? Yeah, not just a coincidence. So those moving electrons allow electricity. That's what electricity is, moving electrons. But you can get moving positives as well, like back in the battery I had up here, drawn up here a minute ago, the Wetzel battery. You get positives which can float around, and those can cause electricity as well. But when we're talking about electrical circuits, and we're talking about batteries producing electricity, we're talking about electrons. So that's the important one, the electrons. So the electrons, they don't like each other. Electrons do not like each other, so they will migrate. When this redox reaction is happening, releasing these electrons, those electrons will migrate to the outside. And I've taken off the cover of this Duracell battery, and you can see all it did is it just took the plastic cover off. And I take the plastic cover off, this is what you have, and it's just a metal casing. It's zinc. I zinc, therefore I am. A philosopher once did that, very smart person. And so this is going to be a zinc casing, and then zinc is metal, and the electrons migrate to the, you could actually put a wire around the outside. It doesn't have to be actually on the terminal. You can get a light bulb to light up because the electrons are moving to the outside. And what we do is you put a wire down here on the negative side of it, and the electrons will move around that wire. Yeah, they'll move around the wire, and then maybe we have a light bulb here. We can light up the light bulb, and we would connect a wire back here to the top positive terminal because the electrons are trying to get to the positive terminal. They're attracted to it, and while they're moving along trying to get to the positive terminal, we can have them go to work, okay? No free lunch, you people, you electrons. No free lunch for you, okay? You are going to do some work on the way back around. Yeah, and that's what a battery does. A battery releases these electrons. It doesn't do it very quickly. Electrons are released. As a matter of fact, they're released all the time, even when the battery is just sitting around. Okay, the electrons are being released. The chemical reaction keeps happening. And that's why they have a shelf life. Batteries have a shelf life. They're not going to last forever. They're eventually going to die. This one is 2025, although it's got crusty crap coming out of the bottom of it. So I don't know what that's all about, okay? Come on, Duracell, make something better than that. So you're talking about a shelf life on a battery because this reaction within the pasty stuff is happening all the time, releasing these electrons. Of course, when it's not being used, releases them very slow. There's something in chemistry called le châtrier. Le châtrier, it's a French guy, so châtrier. And he has this principle saying that if you stress a system, the system reacts to the stress. You sound like you're talking about chemistry. Stop, please stop. Sorry. But the point is, if you're using a battery, if you use the battery and using a flashlight, light bulb, clicker thing, or whatever you're using it in, that will tend to draw more electrons, causing this reaction to speed up inside. When that reaction speeds up, now we have more electrons being released, and you're using a battery. As you're using it, eventually it'll die out because you're speeding up the electrons. And there's only so many of these bad layers you're going to be able to put out from the battery. Oh, and this is called, I call it the buildup of the poop. So you can have a battery that's 1.5 volts and register, let's say, 1.2 volts, but it doesn't work anymore. Your flashlight doesn't work. How come the battery has 1.2 volts? Come on, you lazy battery. You still have some voltage left. Do some work, you lazy Larry. Well, the thing is, what happens is that when this redox reaction takes place, and we're releasing those electrons, all right, the electrons are, there's a reaction, it's a chemical reaction. It's a double displacement reaction, by the way. I know it's chemistry. Chemistry is sometimes has to be mentioned at least. It's compound plus compound makes a compound plus a compound. And these compounds that get made, we also get electrons released, which we want. We want those electrons released, but these new compounds start to build up in here. Well, I'll put that as a different color. Here's a horse of a different color. Put that as a different color. And those compounds that get produced as a result of the chemical reaction are non-conductive, and they're less conductive. They're not allowing the electrons. Once you start building that up, the electrons can't get through anymore. So you can still you can have a voltage, meaning you still have chemical to react. You can still make these electrons, but the electrons just kind of can't get through the poop. Like, oh, all this crap builds up, all this poop, and all that crap builds up and poop builds up. Eventually, your battery will die. And you know this is true if you've ever watched a flashlight. Watch a flashlight, turn it on, and just watch it. It's good, clean family fun. Fun for the whole family. Yeah, just watch the flashlight, and eventually what happens to the light bulb? It doesn't just go, dead. No, it goes, dimmer, 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 dimmer. Right, you'll see it, no, gone. It takes a while to do that because what's happening is this non-conductive poop is building up inside the battery, and that doesn't allow the electrons to move as easily, hence the dimming and dimming and dimming of the light. Okay, whew, I am talking a mile a minute here, but when I get this video, we gotta, and so here we go. So that's batteries. So batteries are electron releasers. Here's the big difference between a battery and a capacitor. A battery is an electron releaser. It releases these electrons. Doesn't do it very fast. If it does start doing it fast, you can feel a battery that's working. It gets hot, it gets warm. The chemical reaction is exothermic, puts some heat out. You can feel that reaction happening, but it still doesn't do it very, very quickly. Batteries can only power, certain things that don't have to put out too much energy all at once. That's where the capacitor comes in. Boop, boop, boop. This is a capacitor. Looks like a battery. I know it does. It has two terminals on it. It does look like a battery, but it's not. It's a capacitor. This is the too loud capacitor. It was used for one of my students' car stereo things, and he was done with it, so we brought it in. This is actually a 1 farad capacitor, which is amounts of capacitance. Well, let's talk about that. What's capacitance? Capacitance, let me give you an analogy of what a battery is versus a capacitor. Okay, you ready for my analogy? It's an awesome analogy. Actually, maybe I can show you. Let me turn you sideways. Okay, you can see over here I have a sink. A sink, not a zinc. I zinc for therefore I am, but a sink. And a battery would be the faucet. Okay, ready? Turn the faucet on. You get it so you get a few drips. So it's dripping, wait for it. Ooh, this isn't easy, Okay, dripping, we got drips. That's a battery. A battery will produce these drips, dripping very slowly. I'm gonna speed it up just a little bit. Come on, you can do it. Yeah, that's fine. So the battery is producing, oh, that was interesting, this big air bubble. Well, that's just cool. Producing these electrons. The water is analogous to my electrons that are being released by the battery. Even if the battery's not being used, remember, those electrons are being released. So we're releasing those electrons. The capacitor is my beaker. What I can do with the capacitor is catch those electrons. And I'm catching those electrons. It's taking some time, but it's building up the amount of electrons in the beaker. Water in the beaker. Water is, remember, the water is my electron. So I'm collecting this water / electrons. I'm collecting the electrons from the battery. So my battery is producing these electrons, not very fast. It produces them, but not very fast. And after a while, I'm collecting. I can get myself a whole bunch of those electrons stored. Ooh, that's what a capacitor does. It stores electrons. Now, why would you want to store these electrons? Why would you want to do that? Because that can do a lot of work. Okay, that can do a big job. When you have just a few electrons coming out of a 1.5 volt battery, there's only so much you can do. It's good. It can light a little light bulb. But if you want to do a big job, like a strobe light, think about a strobe light. A strobe light goes, oh, boom, 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 blah, blah, blah. Whoa, big and stroby. You need more. That's a capacitor. It's very quickly will store some electrons and spit them all out at once. You can do a much bigger job. So if I want to do a job, I take this and I go, do the job. Whew, electrons all gone. I released them all at once, and they will do a much bigger job than when I just had the battery by itself. So the batteries can't do big jobs. In order to do a big job, you need a capacitor, because that capacitor will store those electrons coming from the battery and allow you to go, vroom. Oh, speaking about vroom, strobe light, you've ever had your picture taken? Come on, you know you have. You had your picture taken, and a professional person has a flash unit. And they you know, and they'll take a picture of you, but they have to wait until they, you know, the next picture can be taken with a flash unit, because the flash unit has a capacitor, because a flash is pretty bright. Whoa, 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 dude, yeah, that's bright. That needs a capacitor to give you that amount of to make that bright light go up. So what happens is you'll hear the capacitor actually recharging. So somebody takes a picture of you, and you'll hear. You'll hear that recharging high-pitched sound as the capacitor builds up, grabbing electrons, grabbing electrons, grabbing electrons. Okay, it's ready. Now you're ready to throw those electrons out and give you a nice big flash. So capacitors are used in all kinds of electronic devices. If you were to open up any electric device, anyone, you're going to see multiple capacitors that are storing energy to do a job within that electronic device. So what do we have? Bottom line, batteries release electrons through chemical reactions. Capacitors store them for a big job. This could store an awful lot. Check this one out. This is the inside of a capacitor right here. I opened up the capacitor. This is a 30 microcoulomb capacitor. It's actually about the same size as the battery. You can see they're about the same size here. And it was about the same thickness, the battery capacitor. The capacitor has 2 layers. Here is the unraveled, some of the unraveling that I did. This thing has mucho metal, but it's all wrapped up. It's all wound upon itself. And what you have is you end up getting 2 layers of metal with an insulator in the middle. All right, so 2 layers of metal with an insulator in the middle. Now that's called a dielectric. In a video just not too long ago, I said, hey, I'll teach you about capacitors, and I actually had one drawn out. I didn't really refer to it as a capacitor. Well, maybe I did. But a capacitor, a parallel plate capacitor, a parallel plate has a positive metal plate and a negative metal plate, and in between there is some insulator. That's called a dielectric. Dielectric is a fancy word for some insulator in between. And that insulator doesn't allow the electrons to transfer from here, because this is your negative plate. This is where you're building up the electrons to the positive plate until you're ready to do it. So you have to, you know, maybe press a button or push those 2 things close to each other so they'll discharge. But you get this storage on this plate, and it wants to transfer to this plate. And it can transfer from here to here when you're ready to do that. Maybe push a button, get these 2 plates close enough together where there's a discharge. So you have this parallel plate capacitor, and here I have 2 layers of metal, and in between those 2 layers of metal, there's, it looks like to be cellophane. This is an insulator. And that's all wrapped up and wound together. And all that metal can store so many electrons. When you wind up the capacitor like that, you get that layer upon layer upon layer upon layer of metal. You unravel that, that's a lot of metal, okay? A lot of metal. And now this bad Larry, we open up this and unravel this, there would be a crap ton of metal, and that means more area for electrical storage. The bigger this metal sheet is, the more electrons you can store. So this is a 60 microcoulomb. This is 60 microfarad. Capacitors measure something called farads. And this one is a 1 farad. 1 farad, you don't want, if this thing was fully charged and you were to like discharge it, right here, right across the chest, yeah. Put some salt water right there and take this and go, dead. That is a crap ton of energy coming out of that. All right, there's a lot of energy. Okay, so, I'm babbling on. I know this is a long video. I don't like long videos. I'm trying to make them shorter. I'm getting better at it. But this one, to go through, it took a long time. And I'm talking fast as well. And I didn't say so many jokes either. Okay, so, so difference, battery releases electrons, not very fast. It can do some small jobs. Capacitor stores electrons, grabs those from the battery, stores them, builds them up, and then you can do a much bigger job when you release all those electrons all at once. Capacitors, parallel plate capacitors. Okay, you have 2 metal plates, an insulator in between, and with the battery, you've got chemicals inside that are going to go a redox reaction, releasing those electrons. And I think I got this at least under 20 minutes. I know, I'm sorry, I apologize. It was a long video, but I hope you stuck with me. I hope you learned something today. Okay, all right, I'm here for you.